Welcome to David Alexander Maths Tuition. This is chapter 3C on geometric sequences. Okay, so for a geometric sequence, we're using this formula where the nth term is a multiplied by r to the power of n minus 1, where a is the first term, r is the common ratio, which means what you're multiplying by to go from one term to the next, and n is the number of terms. Okay, so if it's an arithmetic sequence you're adding, for geometric we are multiplying. So here, to go from one term to the next, we are multiplying by 3. So in this sequence, a is 2 and the common ratio is 3. So therefore the nth term is 2 multiplied by 3 to the power of n minus 1. So if we wanted the value of u50, so the 50th term, that would be 2 multiplied by 3 to the power of 49, which would be an incredibly large number. Probably not very realistic for me to type this into my calculator. Maybe I should have chosen something a bit lower. In fact, why don't I try u5? That would be 2 multiplied by 3 to the power of 4, and 2 multiplied by 3 to the power of 4 is 162. So the next term would be 162. Let's check that out. What is 54 times 3? It's 162, so you can see that that works. So remember that the nth term of a geometric sequence is a r to the power of n minus 1. Okay, so for these questions, we're remembering that un is a r to the power of n take away 1. So for the first example, it's going to be 4 multiplied by, what is the ratio? We're multiplying by 4. And we want the 10th term. So if n is 10, then this is going to be 4 multiplied by 4 to the power of 9, and 4 times 4 to the power of 9, which is the same as 4 to the power of 10 for the whole thing. It's quite a large number. 1, 0, 4, 8, 5, 7, 6. Fairly straightforward. Okay, so we want the 10th term here. So it's our first term, which is 3, multiplied by the common ratio. So to go from 3 to negative 6, we're multiplying by negative 2. So that's minus 2 to the power of 9. Just be careful, it's minus 2 to the power of 9, not take away 2 to the power of 9. It's negative 2 needs to be in brackets. So 3 times minus 2 inside the brackets, all to the power of 9. And that is negative 1536. Okay, so for this last example, so we've got no problems with the A. A is 2.4 multiplied by the ratio. So what do I go from 2.4 to 2.04? Well, that's the same as doing 2.04 divided by 2.4, and that is 17 over 20. Maybe I'll just write that as a decimal. Yeah, let's go for 0.85 to the power of 9. So we are multiplying by 0.85. Let's just double check. What is 2.04 times 0.85? Is it 1.734? Yes, it is. Okay, so all we need to do is 2.4 multiplied by 0.85 to the power of 9, and we are getting something fairly hideous actually, 0.55588 06711. Anyway, the answers themselves are fairly irrelevant. You can just see how we are using this formula. So remember, the nth term of geometric sequence is ar to the power of n minus 1. Okay, so this question's not actually that difficult. It's just sort of like the wrong way round, really. So remember that the nth term is ar to the power of n minus 1. So the second term, that would be a times r. So ar is 24. And the sixth term, that would be ar to the power of 5 equals 1944. So if ar is 24, then a is 24 over r. And if ar to the 5 is 1944, then a is 1944 over r to the power of 5. So we've got two equations for a. So what we can therefore say is that 24 over r must equal 1944 over r to the power of 5. We're going to cross multiply. 24r to the 5 is 1944 over r. So we can say that 24r to the power of 4 is 1944. So r to the power of 4 is 1944 divided by 24, which is 81. So therefore r is 3. So the common ratio is 3. And we know that the first term AR is 24. Well, if I know that R is 3, then 3A is 24. So therefore A is 8. So the first term is 8. Okay, a geometric sequence has first term 3, so we know straight away that A is 3. Fifth term, so the fifth term, that is AR to the 4. So AR to the 4 must equal 117.1875. And we know that A is 3, so 3R to the 4 is 117.1875. So therefore R is going to be, well, R to the power of 4 is 117.185 divided by 3. 117.1875 divided by 3 is 30, actually let's leave it as a fraction, 625 over 16. So therefore R is going to be the fourth root of that, and that is going to be 2.5. Now it does say two possible values. Sometimes it might not say two, it might just say the values, plural. So you need to remember that since this is an even power, we can also get plus or minus 2.5. So R is 2.5, but R could also be negative 2.5. So we need to work out the eighth term. Now the eighth term is AR to the power of 7. So that is going to be A, which is 3, multiplied by 2.5 to the power of 7, or also 3 times negative 2.5 to the power of 7. Well, what is 3 times 2.5 to the power of 7? That is a fairly horrible number. I'm just going to round it a little bit. 1831.1 to one decimal place, and 3 times negative 2.5 to the power of 7 is of course the same thing, it's just negative, so minus 1831.1. So yeah, just need to be careful that when you're when you're square rooting or taking the fourth root or any even root, there is a negative and as well as a positive solution there. Okay, so there's a question quite similar to this in the book. It's not very nice. First term is 300, so therefore A is 300. And if the fifth term is 19.2, then we can say AR to the 4 is 19.2. Now we know that A is 300, so therefore 300 R to the 4 is 19.2. So R to the 4 is 19.2 over 300, and that can be simplified. R to the 4 is positive 8 over 125. Okay, so what we need to do is take logs here. So log R to the 4 is log 8 over 125. With log laws, we can bring the power down to the front. So 4 log R equals log 8 over 125. So therefore 4 log R, take away log 8 over 125 is 0 as required. So now we need to find the value of R. I'm actually going to use this equation here. So what is the log of 8 over 125? So remember that is log 10 of 8 over 125. And I'm getting some fairly nasty value. So remember that is 4 log R's. So I'm going to divide that by 4. So therefore the log of R is, can't read my calculator here, negative 0.2984. So therefore R is going to be 10 to the power of minus 0.2984. So 10 to the power of answer, 10 to the power of answer. And therefore we can say R to three significant figures is 0.503. And we're done. Not a very nice one, that one. Okay, so we know that the second term is 4.8, so AR is 4.8, and the fifth term is 8.2944, so AR to the 4 is 8.2944. So if I divide this equation by R and this equation by R to the power of 4, I've got two equations for A. So 4.8 over R equals 8.2944 over R to the 4. Cross multiply, so 4.8 R to the 4 equals 8.2944 R. Divide both sides by R, so 4.8 R cubed is 8.2944. So R cubed is 8.2944 divided by 4.8. So 8.2944 divided by 4.8, which is 1.728. And now I just need to cube root that, and r is 1.2. And if r is 1.2, a, the first term, is 4.8 divided by r. 4.8 divided by 1.2, a is 4. Right, I'm just going to clean the screen now. So from the previous part, we need to remember that a is 4, r is 1.2. Find the smallest value for h where the hth term in the sequence exceeds 152. So here it's h, not n, but it's basically the same thing. So a times r to the h take away 1, we're going to make it equal 152. So remember that a is 4, so 4 r to the h minus 1 is 152. So therefore r to the power of h minus 1 is 152 divided by 4, which is 38. Now we also know that r is 1.2, so 1.2 to the power of h minus 1 is 38. So what I can say is that h minus 1 is the log 1.2 of 38. So therefore, let's just type that in, log 1.2, 38, that is 19.95, but that's h minus 1. So if I add 1, I'm going to get that h is 20.95. So remember that h is a term in the sequence, so it's either the 20th term or the 21st term. The 20.95 will give me 152, so we just need to round it up so that it exceeds 152. So here h is going to be 21. Okay, so remembering that h is 4, r is 1.2, is it possible for 4 multiplied by 1.2 to the power of n minus 1, is it possible for that to equal 24.76694,569? Well, first of all, I'm going to divide that number by 4. 24.76694,569 divided by 4 is, so what we'll have here is 1.2 to the power of n minus 1 is 6.1917. So therefore n minus 1 is log 1.2 of 6.19. I will type it in exactly. So log 1.2 of that answer is 10. So n minus 1 is 10. So therefore n is 10 plus 1, 11. So yes, it is a term in the sequence, and that is generated by the 11th term in the sequence.